This last part of salt preparation still concerns soluble salts. As covered earlier, we are going to use an acid-base type reaction because this makes the byproducts easier to be removed. But what happens if we cannot find an insoluble base for the metal cation? Common ones such as, for example, we are looking at sodium salts. Now we know all sodium salts are soluble, therefore the base of sodium, like sodium hydroxide or sodium carbonate, are all soluble. So this type of preparation will concern salts that involve sodium, such as sodium chloride, or we could even look at potassium chloride and sodium carbonate, even things like sodium nitrate. So how do we go about preparing a salt when we cannot find an insoluble base? For example, let's use sodium chloride. Now we know sodium chloride, we need to add sodium and chloride. So for sodium, we use a soluble base of sodium, maybe sodium hydroxide. We add this with hydrochloric acid. This will give us sodium chloride and water. Now we see three terms that are in the aqueous form, and this is the only one that we want. We don't care about water because that can be easily removed. But how do we make sure that sodium hydroxide and hydrochloric acid has completely reacted such that both are not in excess? So we have to add them in the exact stoichiometric amounts. Well, one way which we have learned is to use titration. At titration, we can find the endpoint. However, in titration, to find that endpoint, we needed to add an acid-base indicator. So what are we going to do with that indicator? Well, in that case, we have two options. One, we could find the option number one is to find the exact amount of sodium hydroxide and hydrochloric acid that needs to be added. Using the indicator. Then 2, we throw this away. And 3, we then repeat but this time we do not add the indicator. because we already know the exact amount of sodium hydroxide and hydrochloric acid that needs to be added based on the first titration results. Of course, an alternative way to this is to first do the titration, and then we can also add activated charcoal, activated carbon, which will absorb the indicator, and we then filter it away. And of course, to end it all, we then evaporate the water. But when do we use this? If you can see, there's a lot of steps involved in this salt preparation. There are also a lot of difficulty in adding activated carbon, filtering out, or repeating this experiment. Therefore, this is always used as a last resort. Only the case where we cannot find an insoluble base to react do we ever resort to this. If we have to resort to this, therefore we would always use the simplest of the base, which is the hydroxide base. Thank you.